Water in games isn't just a simple blue square. It's one of the toughest physics challenges developers face. Simulating splashes, ripples, or even water getting absorbed by sand requires complex math to mimic real-world behavior like surface tension and fluid dynamics. Unlike basic animations, this involves solving equations in real time, making it both impressive and technically demanding. When water splashes in a game, it's not just an animation, it's physics. Developers simulate real-world behavior using fluid dynamics. Viscosity measures how thick or sticky the liquid is, like honey versus water, while density determines its weight. These factors affect splash size and how water interacts with surfaces, like sand. Real-time calculations make splashes look dynamic and realistic, not just pre-made animations. Sand isn't just a backdrop. It's one of the toughest materials to simulate realistically in games. Unlike liquids, sand behaves like tiny particles with friction and gravity, making it clump, settle, or even erode over time. But developers can't just model every grain that would crash any game. So they use shortcuts, like treating sand as a fluid with a twist, adding jitter to mimic how real grains shift slightly when you touch them. It's not perfect, but it tricks your brain into believing it's real. And the best part? But it tricks your brain into believing it's real. This same tech powers everything from beach games to construction sims, making virtual worlds feel surprisingly tactile. Water in games isn't just a pretty backdrop, it's a simulation of real physics. Developers use fluid dynamics to calculate how water splashes, ripples, or gets absorbed by sand. Viscosity, thickness, and density, weight, play key roles. These calculations happen in real time, but shortcuts like particle systems balance realism with performance, tricking your brain into believing it's real. But water isn't just in oceans. It's also in the sky. Clouds are another wild example of how games fake reality. Developers use the same fluid dynamics tricks to simulate clouds, but with a twist. Instead of modeling every drop, they treat clouds like floating blobs, adjusting density and movement to mimic wind currents. Some even add turbulence to make them ripple realistically. It's not perfect. Real clouds are chaotic, but it's close enough to trick your brain. The result? Sky that looks alive, with no actual weather simulation behind it. Games simulate realistic water and sand, but perfect physics would crash systems. Developers balance realism with performance. Sand uses jitter to mimic grains, while water calculates splashes in real time. Clouds are floating blobs with turbulence tricks. This trade-off ensures games feel alive without lagging. Games fake physics for speed, but even the best simulations have limits. Floating objects may hover unnaturally or sink too fast because developers simplify fluid dynamics. Real water would need complex equations for every drop, impossible in real time. Instead, they use shortcuts like particle systems, tiny digital particle systems, tiny digital particle systems, tiny digital particles that mimic behavior to balance realism and speed. Sand physics can glitch, like grains sticking together or disappearing too smoothly. These aren't flaws, they're trade-offs to keep game running. Imagine if games could predict how water behaves before it even moves. That's what AI-driven physics simulations are starting to do. Right now, developers use shortcuts like particle systems or blobs for clouds to fake realism. But with models like Kimi K3 or Claude Fable 5, games might soon simulate every drop of water or grain of sand in real time. These AI tools solve complex equations faster than ever, making waves ripple, sand shift, and even clouds drift like the real thing. The catch? It's expensive, literally billions of calculations per second, but the result could blur the line between game and reality forever. Games make sand look real, grains shift like they should, but it's not perfect science. Real sand isn't just tiny particles, it behaves like a fluid with its own rules. Avalanches happen when grains lose stability, and compaction occurs as weight compresses layers below. Games simplify this for performance, using shortcuts like jitter to mimic shifting grains. But in reality, sand is unpredictable. It can collapse suddenly or resist movement unevenly. These trade-offs keep games running smoothly while fooling your brain into believing what you see. You've probably seen games where water sloshes like it's real, waves ripple, foam sprays, and light bends through the surface. But here's the catch. Most games don't actually simulate every drop of water in real time. Instead, they use shaders, mathematical rules that tell the GPU how to render water visually. These shaders mimic refraction, like how light bends when it hits water, and reflection, making surfaces look wet or glossy without calculating physics for each particle. Foam is another trick, making surfaces look wet or glossy without tracking individual bubbles. Game staves simulate spray. Sand works similarly. Grains shift based on pre-calculated patterns rather than simulating every grain's movement. It's a balance between realism and performance, but it fools your brain into believing what you see. Realistic physics isn't just about cool visuals, it shapes how you play, experience stories, and trust what you see on screen. Imagine a game where water flows like real life, sand shifts under your feet, or clouds drift with the wind. These details don't just look nice, they make the world feel alive, pulling you deeper into the game. Developers balance realism with performance, using tricks like shaders for water and pre-calculated patterns for sand. But as AI gets smarter, games might soon simulate every drop or grain in real time, blurring the line between fiction and reality. The question is, how far will they go? And what happens when games start to feel too real? Games make water and sand look real, but they don't simulate every drop or grain in real time. Instead, developers use shaders for water, mathematical rules that tell the GPU how to render waves, foam, and light refraction without calculating physics for each particle. For sand, they pre-calculate patterns to mimic shifting grains, balancing realism with performance. These tricks fool your brain into believing what you see, making the world feel alive. But as AI advances, games might soon simulate every detail in real time, blurring the line between and reality. Games make water and sand look real, but they don't simulate every drop or grain in real time. Instead, developers use shaders for water, mathematical rules that tell the GPU how to render waves, foam, and light refraction without calculating physics for each particle. For sand, they pre-calculate patterns to mimic shifting grains, balancing realism with performance. These tricks fool your brain into believing what you see, making the world feel alive. But as AI advances, games might soon simulate every detail in real time, blurring the line between and reality. Games are getting scarily good at faking reality: water that splashes like the real thing, sand that shifts under your feet, and clouds that drift just right. But here's the wild part. They're not simulating every drop or grain in real time. Instead, developers use shortcuts like shaders for water, mathematical rules that trick your brain into seeing waves, foam, and light without crunching every particle. For sand, they pre-calculate patterns to mimic how grains move, balancing realism with performance. These tricks make worlds feel alive. But as AI gets smarter, games might soon blur the line between fiction and reality. The question is, how far will they go?